Hello dear students, good morning. Today we are going to discuss a very new topic in front of you. So we will be going into this topic through examples. See, the topic name is linear momentum. You are not at all familiar with this topic, isn't it? So we are going to discuss what is this linear momentum. Already we discussed force. We defined force and we explained what is balanced force, what is unbalanced force, and we gone through Galileo's observations about balanced and unbalanced forces. After that, even based on the force, external force applied, Newton's first law of motion we explained. Then we discussed about inertia also. Now we are going to another topic, that is we are discussing what is the impact of some motion or force. Impact of motion or force, that we are discussing in this topic. See, just imagine someone throw you with a piece of paper that is folded and made into shape of the ball, and throw with that paper ball into your body. Do you get hurt? No, isn't it? Or if someone uses a very small stone, and throw very slowly into your body, do you get hurt? What happens if the same small stone is made to put in a pistol and shoot you? We will get pain, isn't it? It may hurt, even it may bring danger to our life also, isn't it? So there plays a thing. For a motion with a small speed, that does not make any impact on us. But if the same thing that is made to have a motion with a very high speed, that is using a pistol, if we fire the same thing using a pistol, we get hurt. That means something in that motion makes the impact, that is its speed or velocity. So we get the first point, which makes the impact of motion, that is velocity. So we know what is velocity or speed, isn't it? We already discussed what is velocity many times. Now another examples. Now the person is not at all using a pistol or something, he is using his hand only, but not the paper ball or very small stone. He bring a very big rock and put it in your body with a very slow or with very small speed. What happens? You put it very slowly, you do not give any velocity to that. Sometimes it will be having only 1 meter per second or 0.01 meter per second. Do you get any impact on your body? Yes, of course, isn't it? So what plays there is the mass of that, isn't it? So mass and velocity, if either one of them is greater, we get hurt. If someone made a paper ball, very big paper ball, has as much size of a rock that already been put upon your body, someone bring that much sized paper ball and throw at you, do you get hurt? No, not at all, isn't it? Because it does not have the mass. And if someone brings or put a paper ball in the pistol and shoot at you, do you get more hurt as in the case of a stone or in the case of a bullet? Do we get hurt? No, because its mass is too little. And even if the mass is too high, if its speed is very much low, very much low, then also the impact is less. If you are walking through the road, if a truck that will be 4 or 5 tons of weight, 5 ton means 5,000 kilogram. So when it hit us, if the truck is even moving with 5 meter per second or 4 meter per second, we will get hurt and even we may go to danger. Our life may be in danger if we get an accident with a 5 meter per second passing truck, isn't it? So this mass and velocity, that both plays role in the impact of a motion. So here we introduce another physical quantity that measures the amount of impact of motion. This physical quantity is called linear momentum. So linear momentum is defined as the product of mass and velocity. Up to this I just given an introduction to this linear momentum. So what is linear momentum now you may be understood. It is the measure of impact of motion, and it is defined as the, if you are asked to define linear momentum, you have to give the definition. It is defined as the product of mass and velocity of a body, and it is denoted by the letter P. Letter P. P is equal to, in equation form we can write this P as P is equal to, what is the symbol of mass? M, and symbol of velocity V. So P is equal to M into V. Velocity is a vector quantity, hence we give vector symbol here. And momentum, since or hence velocity is a vector quantity, this momentum is also vector quantity. Since velocity is vector quantity, momentum is also vector quantity. So here we get the equation P equal to M into V. That is the equation for linear momentum. So this is a new topic. Linear momentum is defined as the product of mass and velocity, and it is represented by using the letter P. Vector P is equal to M into V, where M is the mass of the object and V is the velocity with which the object is traveling or moving. Now we have to give, or we have to derive a unit for P. What is the unit of mass? Kilogram, isn't it? What is the unit of velocity? Meter per second. So let us derive a unit for momentum. We know the unit of mass, that is kilogram, and unit of velocity is meter per second. So together we can write the unit of linear momentum. Unit of linear momentum equal to kilogram meter per second. And linear momentum is which type of quantity? Vector or scalar quantity? It's a vector quantity, since velocity is a vector quantity. Now let us go to some problems. How can we do problem with this linear momentum? How can we find the linear momentum of a particle? So we'll go through some examples. So suppose an object of having 2 kilogram, and it is traveling with a speed of 5 meter per second. Object of 2 kilogram is traveling with a velocity of 5 meter per second. Then what is the linear momentum of this particle? We know the equation for linear momentum is P is equal to M into V. So it becomes 2 into 5. 2 into 5, which is equal to 10. And its unit is kilogram meter per second. P is equal to 10 kilogram meter per second. That is the unit of linear momentum. So is the answer? Now let us check some of the cases. So first case 1. Let me rub this part, okay? So here we are going to 2 cases. First case, okay, first case. Let the mass be doubled. What happens if the mass is doubled? If mass is doubled. So let's take this example itself. We know the equation for linear momentum equal to P is equal to M into V. What happens if the mass is doubled? 2 becomes 4. So here we'll use 2 into 2 kilogram, and V is equal to 5 meter per second. So 2 into 2 equal to 4 into 5, which is equal to 20 kilogram meter per second. See here, at first it was 10 and now it is 20. So if the mass is doubled, what happens? That is, momentum is also doubled. So mass is directly proportional to momentum, or simply we can write, if the mass is doubled, momentum is doubled. Instead of momentum, I write here P, you have to write momentum. So if the mass is doubled, linear momentum is doubled. Now we can check what happens if velocity is doubled. That is case 2. Case 2, if velocity is doubled. So let's check what happens if velocity is doubled. So in the same example, mass let be 2 kg itself. Velocity instead of 5, it is doubled. It is now 5 meter per second. So P is equal to m into V, m equal to 2 and V is equal to not 5, it's doubled. So it becomes 10, 2 into 10 is equal to 20 kilogram meter per second. See here, if velocity is doubled, then again P is doubled. Now the last case, that is case 3, if both mass and velocity is doubled. What happens if both mass and velocity is doubled? Equation is P equal to m into V, which is equal to m becomes 2 into 2, that is 4, and V becomes the double of 5, that is 10. 4 into 10, which is equal to 40 kilogram meter per second. So what happens if both mass and velocity is doubled? If both mass and velocity is doubled, P becomes 4 times, that is, linear momentum becomes 4 times of the initial linear momentum, isn't it? It was 10 kilogram meter per second, and now it changed into 40 kilogram meter per second if both mass and velocity is doubled. So this is our topic, linear momentum. Hope you understood. Linear momentum is simply just the measure of impact of a motion. So it is defined as a product of mass and velocity. It is represented by using the letter P. P is equal to m into V, where m is the mass of the object and V is the velocity with which the object is moving. Unit of linear momentum is kilogram meter per second, and we derived as from the unit of mass and by the help of unit of velocity. And now linear momentum is a vector quantity since velocity is vector quantity. So it's a vector quantity, we got that. And when we consider the 3 cases, we got that if mass is doubled, linear momentum is also doubled, or if velocity is doubled, linear momentum is doubled. If both velocity and mass is doubled, linear momentum becomes 4 times of the initial linear momentum. That is the conclusion we got here. Now I think you are able to do even the problem section also, because it's just direct substitution in the equation. So only one equation, P is equal to mv, and if you know mass and velocity, we can directly substitute their values and find the linear momentum of a particle. Okay, now we will be discussing more about this linear momentum, application of linear momentum. You see that when in the cricket match, when the cricket fielders, they are taking the catch, when they are taking the catch, there will be what happens, they will be pulling their hands backwards, isn't it, when they are getting the catch. For what they are doing this? They are actually reducing the speed of the ball. If the speed of the ball is decreased, what happens? Momentum will be decreased, that is, impact of the motion will be decreased, hence they will not get hurt their hand. One thing is that either we have to decrease mass or we have to decrease velocity to decrease linear momentum, isn't it? Mass can't be decreased as it is a cricket ball that is coming from the sky. we can't decrease the speed of a cricket ball at that moment. So one thing only we can decrease. What is that? Velocity. So the fielders are doing a motion like this towards their end in order to decrease the speed of the ball and in order to decrease the impact of the motion. If there is more impact, it will be more painful. And the goalkeepers also, while they are taking or catching the ball, they will be always doing this action for decreasing the speed of the ball. So we will be discussing these applications of linear momentum in all fields in the coming sections. After discussing Newton's second law, we will be discussing Newton's second law in the next topic, and after that we will be discussing some of the applications of this linear momentum. Newton's second law is based on linear momentum, so you have to understand well this linear momentum, then only we can discuss further topics. So hope you understood the section, and if you have any doubt, you can contact me. See, this is a very important topic, that's why I am repeating. You can contact me. Linear momentum equation, never forget this equation, P is equal to mv. Thank you for watching. Have a nice day.